Hello everyone, welcome to week 3 of the Geoinformatics course at INRS. This week we explored object-oriented programming in Python. This is a fundamental programming paradigm for organizing and structuring complex codes. We begin by reviewing the limitations of imperative, functional, and procedural programming paradigms to justify the importance of OOP. Before we introduce OOP, we present two examples of codes that achieve a same task but with two different signatures, a functional signature and an OOP signature. Then we introduce OOP using the concepts of class and object using an intuitive example from the car industry that illustrates how a class serves as a model or template. It defines the attributes and methods that are common to a set of objects. The same example depicts several objects defined based on specific characteristics of the class, thus they are simply concrete instances of the class. Later on, we discussed the four pillars of OOP. First, encapsulation, which is a mechanism that protects data by controlling access to attributes and methods. We discussed the use of single underscore and double underscore to mark variables as protected or private. We also discussed approaches to create getters and setters necessary to validate and control data access using examples. Second, we look at inheritance, which allows a child class to inherit attributes and methods from a parent class. This promotes code reusability and hierarchical organization while reducing code redundancy. Third, we look at polymorphism, which is the ability of the method to take different forms from a parent class to a child class. We look at techniques for method overriding and operator overloading, such as the plus operator, to adapt behavior based on the context. Fourth, and last, we look at abstractions, which is a simplified representation that hides complex implementation details and exposes only the relevant interfaces. We discussed abstract classes and the ABC module to define abstract methods that subclasses are required to implement. Finally, we explored the Shapely library for geospatial analysis. This library provides predefined classes like point, line string, and polygon to generate spatial objects on which we perform spatial operations and execute geometric queries. Thank you for your attention. I look forward to seeing you next week.